understand the transaction, what do you mean by transaction and what are the different states of transaction, the next step is how to make these transactions concurrent. In the sense, how do we make them operate parallelly, simultaneously on the database. The advantages of making the transactions parallel is that they will increase the throughput of the number of transactions, throughput of the databases. In the sense, the number of transactions that can be processed in a given time, at a unit time, can be thought as a throughput. Then if we can operate parallelly, we can increase the throughput of the databases. Not only that, the response time for the end user, once an end user interacts with the database through a transaction, then what is the response time for the end user also important. That dictates the satisfaction levels of the end users also, query processing times and all. So now the processing time is also minimized when you operate these transactions parallelly. These are the two metrics that we look at when we make transactions parallelly. Then what are the difficulties, or what are the that we face if we make them parallel? There are so many difficulties are also there. We'll talk about the difficulties later. But to what extent we can make these transactions isolated with respect to each other is an important issue here. So we need to devise mechanisms or isolation mechanisms where we can isolate as far as possible. We should be able to isolate these transactions but interleaving the operations of the transactions. We need to control the transactions in such a way that though the instructions of the transactions are interleaved, the consistency of the database is not lost, the throughput is increased, and the response time is minimized. A schedule is a sequence of instructions that are operated in a specific chronological order, and though the instructions are interleaved, there are several transactions, the end effect of the sequence of operations dictates the end effect of the schedule. Though there are several transactions, since the instructions of these transactions are interleaved, the end effect is dictated by the order in which we interleave the instructions in a specific order. And that dictates the end effect of a schedule. And usually whenever a schedule is done and a transaction is over, at the end of every transaction a commit operation is performed automatically. It is assumed that at the end of the transaction, once it is successful, a commit operation is performed. Similarly, whenever a transaction fails, an abort operation is performed whenever there is a failure of a transaction. And when it comes to the serial schedule, once we define a schedule, then we have a concept of serial schedule. So what do you mean by a serial schedule? The idea is very simple. The order in which the transactions enter the database with respect to the timestamps that dictates the order in which they should be processed. Now, if the transactions are performed in the order in which they have entered the database, sequentially one after the other, then the schedule is called a serial schedule. Here is an example of a serial schedule with two transactions, simple two transactions. And in the first schedule, T2 happens after T1. In the second schedule, T2 operates first and then T1 operates. And in the operation T1, we are transferring rupees 50 from account A to account B. And in the second transaction, whatever amount is there in A, 10% of it is transferred to account B. So in the first schedule, T1 followed by T2, we have transferred the 50 rupees, then the transaction committed, and then second transaction started, and then the 10% of amount of account A is transferred to account B. That is one schedule. When you come to the second schedule, for the same set of transactions, this is a different schedule now. T2 happens first and then T1 happens. In T2, whatever amount is there, we have transferred 10% amount from A to B, and then the transaction T2 has committed. After that, T1 starts, and now it transfers 50 rupees from account A to account B. Then just you try out with the sample numbers what could be the end effect of these transactions in two different schedules. Now here we talk about two more schedules, schedule 3 and schedule 4. In schedule 3, if you look at database object A is read, rupees 50 is subtracted from that, and A is written. After that, now second transaction entered, and it performed subtraction of 10% of amount from A. But here the important point is the read A operation of transaction 2 is reading which value of A. Already transaction 1 has written the value of A, so T2 will read the value of A written by T1, that is already subtracted value. Then it performs the actions in the T2 and write A is performed. After that again T1 resumed its action on database object B. It has done something, added 50 rupees to B, and then write B and commit. T1 transaction has been committed. At this stage T2 resumed its action, and it has read the value of B. Again, which value it has read? Written by T1. And then the temporary value is added to that and committed. T2 has been committed. This is schedule 3. Now here, if you look at the values of A and B, they are similar to that of one and transaction schedule 1 that we have seen. Now, if you go to schedule 4, here value A is read, A is subtracted 50, and then transaction T2 has started. Here what happened? Read A operation of transaction T2. Then which value of A is read? Since T1 has read the value and performed some action, but it has not written anything, and hence T2 reads the value which T1 has already read. The same value T2 will also read because T1 has not written by that time. And after that the actions are performed, and write A operation of T1 is performed at the end of actions of T2 in the first step. So like that the remaining operations are also performed. Now if you look at the values of A and B, now they are highly inconsistent. Just you can check it out with values of A and B with sample values. So in the previous slide we have observed that interleaving the operations sometimes or leaving the schedule disturbing the consistency of the database or leaving the database in an inconsistent state. Now here we could have avoided that the inconsistency if we operate the transactions in a serial way, but obviously that is not going to serve the purpose. We need to interleave the operations. So then we need to interleave the operations in such a way that the consistency is not lost. So what should we do now? Now here there is a concept called serializability, where though we interleave the operations of the transactions, the end effect of the schedule should leave the database in a consistent state. Every transaction should be consistent with respect to the database, and every schedule should also be consistent with respect to the sequence in which the transactions are occurring on the database. Now that is the concept and aim with which we need to work now. And we say that two schedules are said to be equivalent to each other on a database if they produce same output with respect to the database objects which are consistent with respect to the database at the end of the schedules. If two schedules are like that, then we call them as equivalent. And the concept of serializability is studied extensively. Two important serializability concepts are well known. One is conflict serializability, another one is view serializability. Now in the next lecture we are going to talk about those view serializability and conflict serializability and the effect of those serializabilities on the databases. Previous slide we observed that the operations of read and write are going to affect the database object in a transaction. Now in this slide let us observe what exactly is going to create a problem, when they are going to create a problem. Now suppose if I take two transactions Ti and Tj, and in their process if they operate on two different database objects, either read or write, we don't mind because they are not going to affect each other because they are operating on two different database objects. The problem comes when they operate on a single database object simultaneously. Again, if two transactions are operating on a single database object or same database object, then the problem arises. Again, in such situation, what are the conditions under which inconsistency may be affected? There are four possibilities here that the transaction T1 may be reading the value of a database object Q, and after that, immediately after that, T2 may be also reading the same database object Q. So if just both the transactions are reading the same database object, it's not going to create any problem. Whereas if T1 has read the value Q and if T2 is trying to write the value of Q, then it may cause an inconsistency problem. Similarly, if T1 has written a value and T2 is trying to read the same value, then it may cause a problem. Or if T1 is writing a value and the same database object is also written by T2, it may also cause a problem with respect to the temporal order or a time order in which they need to process. If the timestamps are good, if even though they involve read and write operations, if the timestamps are good with respect to read and write, that there may be no problem at all. But there is a chance that these operations may create a problem, right? So we need to address only those read and write operations of two transactions operating on the same database object. If II and ij are two instructions consecutive in a schedule and they do not conflict each other, if the instructions are not conflicting each other, then the result would remain same even if we interchange the instructions. That means if two instructions are operating, even though they are operating the same database object, but if they do not conflict each other, then even if two instructions are not conflicting each other, there are two possibilities. Non-conflicting means either they operate on the same database object, but both of them are read, or those instructions are operating on two different database objects. Under these circumstances, even if I interchange the instructions in a schedule, they are not going to create any inconsistency in the database.